This is your lesson on factoring polynomials. It follows the examples in Glencoe 5.4. Now notice that learning target does say 5.3 is also included, and that's because it does discuss the concepts of synthetic division and long division in 5.3 specifically. So please make sure you're looking back at those notes because that is part of this learning target as well. All right, in example 1, we are asked to factor by using the greatest common factor. Just a side note, you should always do this first. Always check to see whether or not there is a greatest common factor. So this is a trinomial here, and I'm looking at these terms, 6x squared y squared, 2xy squared, and 6x cubed y. First, looking at their coefficients, the biggest thing I can pull out from all three terms is a 2. Then I'm looking at all of their x's, and see the smallest one that I have is just a singular x. So therefore, that's actually the most I can pull out of all three of those terms from x's category. Same also follows for y, because it is something I actually need to pull out from everything, okay? When I take 2xy out of the first term, I am left with a 3, because 2 times 3 is 6. And I'm left with a singular x and a singular y. One good way of checking your work is always redistributing this in here. That's, of course, unfactoring. Now we have a 2 on the outside, leaving me with a -1 on the inside. And the only thing that remains for my middle term is a y, because I took away its 2 and its x, as well as one of its y's. The last term, I have 6x cubed y, and I took out a 2, leaving me with a 3. I took out one of its x's, leaving me with 2 more on the inside, and I already took out its y, so this is now completely factored here, okay? The new type of factoring method that we're going to talk about is something called grouping. Now, grouping can be used when there are 4 or 6 or 8 terms. Hopefully you're catching on. There's an even number here, okay? So here are my 4 terms. Now, grouping can be done in any particular order typically. And the way I kind of like to look at it is kind of playing matchmaker here, okay? Looking for 2 of the terms that look like they have something in common here. So looking at my first 2 terms, a cubed and -4a squared, it just so happens they both have an a squared in common. So I'm going to take out an a squared out of both of those terms, leaving me with an a and a -4. Okay? The other couple that I'm going to use is the 3a and the -12. Now something that they have in common is a +3, leaving me with an a and a -4. Now notice that both couples produced a factor of a -4, so I can take what they had individually and put it together here, okay? This again is just like distributive property. Well, let's do this in a different way. Unlike your textbook does, that's the order. But if I wanted to, I can pair together the a to the third and the 3a, just rearranging it in a different order. And then pair together the -4a squared with the -12. Let's play matchmaker here. My first 2 terms, the only thing they have in common is an a, leaving me with an a squared plus a 3. Now my second pair here, -4a squared and -12, they both have a -4 in common. When I take this out, I'm left with a squared plus 3. And look at that. Both of these also now have an a squared plus 3 in common. So now I take their a squared plus 3, create a factor, and now what they had in common individually creates the other factor. Notice that both produce the same exact answer. I just wanted to prove to you that it doesn't matter which order you do it in, so long as they both produce a common factor. Alright, in example 3, we're given a whole slew of types of polynomials to factor, so it's highly important that you get really good at just having that intuition as to what method you're going to use when. Reminder, please always check for greatest common factor first. So looking at A, there is no greatest common factor, so now I know it's a trinomial. So I actually can revert back to my previous algebra skills. The way I learned is called kidnapping, so I'm going to take this 5 here, my leading coefficient, and kidnap him and hide him with my c value here, giving me the new polynomial of x squared minus 13x. And now I took the 6 and multiplied them by a 5 and got a 30. So now I can factor it like I normally do here, where my a is 1. And I ask myself, what multiplies me 30 and adds me -13? Well, the answer would be -10 and -3. Now, kidnapping is highly illegal. So I must now put the 5 back on the inside here of my binomials as a coefficient for x, but notice that 2 came back when only 1 was kidnapped. So to determine the fake, that's what I call him, my imposter, I'm going to look for a GCF in both of these and pull him out and then banish him. So notice that in my first binomial, I can take out a 5, leaving me with x minus 2. My second guy, well, he is the true 5. He was not fake. So the last thing I need to do is erase this imposter from my life. And I have now factored this trinomial here, okay? Now we're looking at B here. So first off, I always check for a greatest common factor, and I'm noticing that both my two terms here can factor out a 3 and an x, leaving me with my expression of y squared minus 16. Now y squared minus 16, this actually can be gone further. This is an example of what is called a difference of two squares, factoring into a y plus a 4 and a y minus a 4. Once again, difference of two squares is addressed in Algebra 1, so please make a note of what it is called. Looking at C, we have the expression c cubed d cubed plus 27. What this expression is the sum of two cubes. And the sum of two cubes is going to follow an expression called SOAP. Okay? And I always like to ask myself, what's really being cubed to produce this expression here? Well, the first term, c cubed d cubed, that's really just cd being cubed. The second guy, to produce a 27, well, that's going to be 3 to the third power here, okay? Now, what does SOAP stand for? That means same sign. So my first expression, I'm going to take these two guys, and the same sign that I'm using throughout here is plus, and I'm going to add them. Now, the O and the AP, O stands for the opposite sign, and the AP stands for the always positive sign. Now, what's going to fill these in here? This first spot is always going to be this first term squared. So we have c squared, d squared. This second term here is always going to be the multiplication of these two terms. So we're going to have, in this case, 3cd. And then this last term, we're going to take this guy here and square him, giving me this final factorization of a sum of cubes. Now, differences of cubes are going to follow the same process of SOAP. So looking at D here, I have m to the 6 minus n to the 6. Now, he could be treated as a difference of squares, but it could also be treated as a difference of cubes, and that's going to take it a step further. So I ask myself, well, what's really being cubed to get me m to the 6th? Well, that's going to be m squared, because m squared to the third power is m to the 6th. And then this is going to be also n to the second here. So my first factor, I bring down my m squared. We have our same sign of n squared here. And then over here, we're going to have our opposite sign and our always positive sign. So I'm going to square my first term here, getting me m to the 4th. My middle term, I'm going to multiply my two terms and then my n term. I'm going to take him, and I'm also going to square him, getting me n to the 4th, giving me now a difference of two cubes. All right, example number 4 is the quotient of two trinomials. So again, you're probably going to be familiar with this content from your Algebra 1 class, and it's important to remember that the only thing you can cancel out are factors. I'm going to make a note. Cancel out factors, things that they have in common here, okay? All right, so the top and the bottom, we can't just cancel out x squared, but we can cancel out factors. So I'm actually going to factor both the top and the bottom. And thankfully, my a is 1, so I'm going to give myself my x's on both of them, top and bottom. Looking at the top, I'm asking myself, what multiplies to be negative 3 and adds to be positive 2? Well, that would be positive 3 and negative 1. Now, on the bottom here, I'm asking myself, what multiplies to be positive 12 and adds to be positive 7? That would be a positive 4 and a positive 3. So notice that both in the top and the bottom of our quotient here, we have a common factor of x plus 3. So these are allowed to simply just cancel each other out, leaving us with a simplified expression of x minus 1 over x plus 4. Now, our answer is not 100% done because we need to remember that we're dealing with a division problem here where there's a variable. And so we need to remember we cannot divide by 0. So x plus 4, what would cause me to divide by 0 would be a negative 4. Now the secret sly thing here is the fact that even though we canceled x plus 3, we also need to remember what would have caused him to be 0 if we hadn't simplified him. Well, that would have been negative 3. All right, so this is now the end of your lesson.